Hello. I hope you guys can hear me. This is going to be another integral stream. Uh, Let me just set up my chat. Then I will go full screen. Okay. Hold on. So last time I did substitution, if I remember correctly. This time I will do integrals involving exponential and logarithmic functions. And hopefully I do inverse trigonometric functions as well. Hopefully, I'm not really sure about that one. But before I do this, I want to do one exercise from the substitution part. Also, it's going to take time to load. Yeah, I should have opened these pages before starting the stream. Never mind, I will just wait for them to load. Okay, so let's just before while they're loading, I just quickly go some of the things I learned last time. So by definition of integration, let's say the area of this is capital F of x. This is this area. Uh, then that means the derivative of this, the rate of change of the area at x is equal to f of x. This is the first fundamental theorem of calculus. The second fundamental theorem of calculus is, uh, let's say we have this line continues. We have another one b. So a to b. The x is defined between A to B, the area of this between A to B is the antiderivative. Let's say A is antiderivative of F. Antiderivative at B minus antiderivative at A. This is the second fundamental theorem of calculus. Hold on. What's happening here? Okay, now it loaded. I don't know why it wasn't loading before. Okay, so let's go down. Let's do some of the questions. I want to do one about definite integral, one with the answer key. Let's do this one. What is this? 297 from pi over 4 to 0. Sine theta over cos. I'll just write it like this. Sine theta cos and d theta. All right. Also wait. I need a reference. Right. Derivative of tan x is minus cos x square. No, wait. Sec squared x Let me think. Should I do tan theta over cos cube theta? Derivative of tan x is 1 over, wait. Derivative of tan is 1 over cos square theta. I have no clue. Uh, Derivative of sine theta is cosine theta. So let's say u is equal to sine theta du is equal to sine cos theta. This is this correct? What if I do this? No, this is not going to work. Or what if I do this? Wait. How about -3? Then -3 -4. Then the derivative of cos theta is negative sine theta. I don't even know if this is correct. If, let's say, f of x is equal to sine x over cos to the power of 4x. Why is this an error? Then what is f of pi over 4? Hold on. Sine pi over 4 sine x is this, pi over 4 is this pi, this is half pi, this is pi over 4. Is it root 2? Hold on. This is pi over 2. Pi over 4 I think is root 2. Uh, yeah, it's a 1 over root 2. Uh, this to the power of 4, 2 to the power of 4 over 2. So if I do f of pi over 4, yeah, I think it's 2 squared 4 over root 2. Zero and 0 would give 0. This is just u, right? So like this. Is this the correct answer? What is it? 297. No, it is not. 2 root 2 minus 1. 1 over 3, 2 root 2 minus 1. Wait, hold on. Wouldn't this be like instead of 4 I can write 2 times 2 and then no, sorry. I'll do this plus and then can do this squared. This sounds more complicated, but I'm trying to get to their answer. Uh, just then 2 plus um hold on, no. This is a minus 1. Two root 2 minus 1. Wait, 4 is like this. 2 times 2 basically, and then one of the root 2 will cancel out, so you're left with root 2. Where did the minus 1 come from? Plus c, no. I don't think it ends at 0. Maybe I'm wrong there. No, u is equal to cos minus 3 theta. But cos 0 is 1. Oh yeah, then that makes sense. This is 1. So it'd be 4 over root 2 minus 1. That would explain everything. This I can write it as 2 root 2 and then negative 1. Right. Next chapter, finally. Wait for this one. Should I separate these two? Like derivative of sec x and then derivative of cos x? Something. I did it for this. Um, Also, notice how I wrote the answer here. I'm thinking I should write the answer on the title as well. So this can be like a reference, and then clicking it would give you the proof. Now integrals involving exponentials and logarithmic functions. The exponential function is perhaps the most efficient function in terms of operations of calculus. The exponential function y is equal to e to the power of x is its own derivative and its own integral. Exponential functions can be integrated using the following formulas. A to the power of x is a to the power of x divided by ln of a plus c. Let me see if I can remember the proof. This. So we want the antiderivative a to the power of x d dx. A to the power of x can be written as e to the power of a no x ln of a and then derivative of both sides. This won't change. So the chain rule, derivative of the derivative with respect to x ln of a, and then derivative of x ln of a with respect to x, which is ln of a. Is this correct? I don't think this is correct. Okay, it is correct. Now we want the antiderivative, right? This is a constant, so I can put this to the other side. This is a constant, so I can do this. Derivative, derivative of this. And then by definition of derivative, I can put a constant inside. So then the antiderivative is a to the power of x ln of x. Do they use the same proof? Or do they use any proof? Nope. Okay, so what's the here? Find the antiderivative of the exponential function e to the power of minus x. Okay, let's erase this. Let's draw a line here. So derivative e to the power of minus x. First you derivate with respect to minus x, and then you derivative minus x with respect to x, which just gives you minus 1. Now putting minus 1 to the other side, since it's a constant, I can put it inside the derivative. I will get this. Is that the answer? Okay. No, I forgot plus c. Find the antiderivative of the exponential function e to the power of x. Hold on. I should start using a line more often. So, um, hmm, let's see how I can do this. If I do u is equal to 1 plus e to the power of x, then the derivative of u, uh, I'll put dx on this side. This is to the power of half. And then with respect to, and then derivative of the inside is e to the power of x dx. But how about this? Instead of to the power of half, it's to the power of 3 over 2. So when I derivate, it becomes half. So this here is 3 over 2. This here is half. So derivative of the entire thing with respect to 1 plus e to the power of x gives 3 over 2, 1 plus e to the power of x to the power of half. And then derivative of 1 plus e to the power of x with respect to e to the power of x is just e to the power of x. Right. So I can do this. And then I can, no, in outside. Then I can just introduce u. And then u here is this. Two to the power of 3, yes. Use substitution with the exponential function 3x squared e to the power of 2x cubed. Three x squared e square x cubed. Let me think. So if I derivate e square x cubed, I get So with respect to 2x cubed, it doesn't change. Now derivating 2x cubed with respect to x, I get 3 times 2 is 6x squared. So that means, let's say u is equal to, I can like write this as 3 times 2 and I can put 2 to the other side, right? I split this to 3 times 2 and then instead of 2 here I'm putting half here. So then this is this. So this is basically like that. And then I get half times e to x cubed plus c. Let's see if I got my answer right. Yes. Okay. Find the price demand equation for a particular brand of toothpaste at a supermarket chain when the demand is 50 tubes per week at 235 per tube. Given that the marginal price demand function derivative of px for x number of tubes per week is given as derivative of p is equal to minus 0.015 e to the power of minus 0.01 x. If supermarket chain sells 100 tubes per week, what price should it set? Okay, let's see what they're asking. So P, what is this? This is marginal price for X number of tubes per week. For X tubes per week. Price demand equation for a particular brand of toothpaste at a supermarket chain when the demand is 50 tubes per week at 2.35 per tube. Oh, this is the price demand function. Oops. Oh no. Price demand function. And the demand is 50 tubes per week at 2.35 per tube. I'm not sure what I'm trying to find, but the equation for price demand is this. 0.01x minus, right? Find the price demand equation for a particular brand of toothpaste at a supermarket chain when the demand is 50 tubes per week. So over here you input the number of tubes and you get the, what do they mean by marginal price demand function? I don't get what they mean by marginal. Okay, never mind this. Um, okay, so derivative e to the minus x this I suppose, then minus, so then this is equal to 1 negative, no, 2 minus, minus 2 minus minus 1, no wait, 2 minus 1 is 1, no, this is correct. Or I should also expand u, so e u is minus, hold on, no wait, I got this wrong. I need to replace 2 and 1 as well. So integral minus integral du. So if you put 2 here, 1 minus 2 is minus 1, e to the power of 1 minus 1, which is 0. But hold on, 1 over e, 1 is bigger than e to the power of minus 1. Let's see what I get. Then this gives me 1 minus, is this correct? Okay, yeah, this is correct. Suppose the rate of growth of bacteria in a petri dish is given by 3 to the power of t, where is given in hours, and qt is given in thousands of bacteria per hour. So when qt is equal to 1, that is 1,000 bacteria per hour, a gain of plus 1,000 bacteria per hour. If a culture starts with 10,000 bacteria, find a function capital QT that gives the number of bacteria. Hold on. QT is equal to 3T. Rate of change of bacteria at time t. The number of bacteria at time t, and t1 means plus 1,000 bacteria at time t. Find a function capital QT um, the number of bacteria at time t. So this integral is equal to 3 to the power of 3 over ln of t. Am I right? Hold on. No, that's the derivative. No. Uh, I need to write the antiderivative as well. So add 0 is 10,000. 10,000 bacteria. But since the number is counted in thousands, I'll just write 10. 10 is equal to 1 over ln of t, t0, then t0 is e to the power of 1 over 10. Is that right? Yes, that is right. No, that is not right, in fact. This is t0. ln of 0 is undefined. So how do I do this? Whoops, wait. It's ln of 3, not 0. Nope. Is this correct so far? C is equal to 9.09. Okay. Now wait. So what am I supposed to find? How many bacteria in the dish after 2 hours? 3 times 3 is 9 minus 1, 8 over ln of 3 plus 10. $17.28. Suppose a population of fruit flies increases at the rate of 2e to the power of 0.02t in flies per day. If the initial population of fruit flies is 100 flies, how many flies are in the population after 10 days? GT is number of flies between times T0 T0 to T. And then, wait, hold on, let me. And then GT is equal to the derivative of this, which is equal to increase the number of flies at time T. So GT is given. So the antiderivative of this wait, hold on. Derivative of uh, E 0.02 T half. Derivative of this is 2 outside times the inside. Uh, so 1 over this, weight 50. I can just write 50 here. 50 times 2 is 100. Now, the initial population of fruit flies is 100 flies. Instead of T, let's call it 0. T is in days. T 100 flies. Oops, this is 100. Then C is equal to minus E 0.02 T, right? So what do I need to find? So wait, GT, this minus this would give you 99. We need it after 10 days. So 99, 0.2. That is the answer. This is about 99 E 120.91. Around 122. How did they get 100 e to the power of 0.2? Wait, G0, this is 0, so the entire thing becomes 1. It's 100, so C is 0. Yeah, I didn't put 0 here. Whoops. Hundred e to the power of 0. So C is 0. So GT is just this. And then, yeah. So C 100 E squared. Why would it be? Oh, whoops, it's in 10 days. Yeah. This is around 100, 122.14. Evaluate the definite integral using substitution. e to the power of 1 over x x squared dx. And then derivative let's say x to the power of minus 1. So with respect to x to the power of minus 1, the derivative doesn't change. And then derivative of x to the power of minus 1 with respect to x is this. So if I put minus the other side, uh, let's say u is equal to e to the power of x minus 1, then that gives minus du e to the power of, wait, hold on. Yeah, x. So then this if I put 2 here, e to the power of half over 4. Is that right? If I put 1 here, it's just e. And then should I just say root like that? Let's see what the answer is. Minus 1. And this has to be minus 2.30, 2.31. Why is it root e minus root e plus e minus root e plus e? What happened here? Oh wait, it's this. I've been substituting this. So e, yeah, it's root e there minus root e plus e. So integrals involving logarithms. Do I have the uh, integral of ln of x? Okay, I need to start putting integral um of all this. Yeah, this is wrong, I think. This is actually about antiderivative 1 over x. The title says ln of x. Okay, I need to correct these mistakes. So 1 over x is ln of modulus x. Integral of ln of x is x ln of x minus x. X ln of x minus 1. This is x over ln of a ln of x minus 1. Okay, I will work on the proof later, or maybe now. Let's see if I can try to do it now. As for ln of x, this function is defined from 0 to infinity. So the derivative of ln of x from 0 to infinity is 1 over x. This makes sense, but this doesn't make sense for the negative part. So what we do is we expand. So when we are finding the antiderivative of 1 over x, if we are doing the reverse, we are finding the antiderivative of 1 over x, we use this. So over here, the derivative is like very steep, a steep positive number, and then the gradient gets flatter and flatter and flatter and flatter, but never zero. So over here you can see the derivative. It's a very high number because it's very steep, and then it gets lesser and lesser, so less and less steep, but it's never zero. Same over here, but at the negative direction. It's opposite and negative. So it starts off uh, it starts off very flat, so that's why it's very close to zero. The derivative is very close to zero, but then as x gets larger, the derivative gets steeper and steeper and steeper. So the negative value becomes larger and larger. So over here, the negative value gets larger and larger and larger. Derivative of ln of x is x ln of x minus 1. Let's see. But I don't really need to derive this. I can just derivate this and get ln of x. But I need a satisfying proof. Let me think. I don't know. I'll just memorize it just like this for now. Ln of x is equal to x times ln of x minus 1, x over ln of a, ln of x minus 1. So finding an antiderivative involving ln of x. Find the antiderivative of the function. So um, they're asking for this, right? Let's see. Derivative of is 1 over x. Or what if I do derivative of x minus 10? What if I do 3? Since this is a constant, it can be taken out and then placed back in after we evaluate the thing. So this would be 3x minus 10 plus c. Yeah. Find the antiderivative of this. Okay, this one looks difficult. Um, u is equal to x to the power of 4. We can imagine this as the whole thing being to the power of 4. So 4, oops, 8. I need to think about this. Derivative of ln of x is 1 over x. derivative wait, derivative of x to the power of 4 is 1 over x to the power of 4 and times the inside x to the power of 3. Huh. Let me think how I can do this. X to the power of 4 plus 3x square for x cubed plus 6x, right, dx. I think this is it. Then I can factor 2 out. And we just need to find the antiderivative. And then I can just evaluate u as ln of ln of that. Let me see. Yes. Oh, I forgot plus c. I keep forgetting plus c. So logarithm when it says x minus 1, it's like the x just the part of ln, or is minus 1 inside ln of x. Let me do this last one and then I will end the stream. So when it comes to 1 over x, Derivative of is ln of x plus c. Let's do 1 plus cos x. And then du is 1 over this. And then derivative of this is minus sine x. So and then I can bring the minus to the other side. Not pi over 2. Whoops. Minus du cos pi over 2. I forgot. Pi over 2 is what is that? No, cos pi over 2 0. Wait, hold on. Okay, cos pi over 2 is 0. So then this becomes ln of 1. Ln of 1 is 0. Cos 0 is 1 plus 1 ln of 2. And then we are left with ln of 2. So 0 minus ln of 2. Right. Guess I will end the stream here then. Yeah, I need to make some fixes in my website. And I hope I finish the trigonometric one in the next stream. So see you guys next time, I guess.